Good afternoon, class. Today we're going to be working a little bit with testing the WPF exercises. So for this one, we're actually going back to the data binding exercise that we built previously, and we're going to add a test project to that, as well as a test document. So if you don't remember, that's the one that we created a little to-do list, and we need to write tests for our to-do list. Go ahead and add that task, and of course when we check them off, that removes it from the list of remaining actions. Okay, so let's talk a little bit about how we can test a WPF project. In a lot of ways, we test a WPF project the same as we would any other project. We can go ahead and create a test project to go with this, or use an existing one if we have one. So in this one, we're going to call it to-do tests. And I'll go ahead and use .NET Core 3.1 because I believe that's what this project was built with. And you can see it pulls in and creates our test project. Notice that it took a moment to download XUnit in the background before those red lines went away, but it's pulling XUnit from NuGet. So it's a NuGet package that's built into this. You can see that if we come down and look at the packages, you see XUnit 2.4.0 is included in this. So we're using that for our testing. And when we test, what we're really testing is just the model classes. So we'll look at, for example, the to-do item, which represents a single to-do item out of our list. We'd want to write test for that, a unit test for that, and then also the to-do list. And I'd like to focus right now on the to-do list because that's the one that's a little bit interesting. It inherits from this observable collection, which means it's going to be creating a collection changed event, and we want to be able to test that that is actually being triggered correctly. This basically dealing with the collection changed event that's firing off. It needs to work in order for our custom logic in here to work. So let's rename this test to-do list unit test, or yeah, let's go ahead and add unit to that. Alright, so we need to test some changes to this to-do list. So the different things we're going to be looking at, our to-do list has a complete count, it has an incomplete count, and those are based on the tasks that are added to it. So we'd want to definitely test those. It should count incomplete tasks. And we would go ahead and do this pretty much the same way that we do any other fact. Of course, this needs to be a void return type. We would create an instance of our to-do list, which we're going to have to add a using statement to bring that in. And actually, that is in the data binding example namespace. And notice that it doesn't recognize this namespace, and that's because it doesn't know about this project yet. So we also have to add a project reference to our dependencies to the project containing that namespace. Once we've done that, this should stop complaining at us. Let's make sure we actually have the right namespace. Data binding exercise, that's why, not example. So data binding exercise. Now we should be able to create a to-do list. And let's add a couple tasks to that. And it doesn't want to use my variable. There we go. So we're going to add a new to-do item. And by default, these should start as false, and we would actually test that in the unit test for the to-do item. And once we've added those 3, we would expect to have 3 incomplete tasks. So we would assert that we're expecting 3 incomplete tasks, and the actual value would be to-do list dot I'm going to change this to TDL because autocomplete is really getting annoying with this. So TDL, 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 TDL. Keeps trying to make me use the actual name of the class instead of the variable that I have created, which is really what we want to be using. So we can go ahead and check complete count, and that should equal 3, provided everything was done correctly. And we can go ahead and build and run the solution. So we'll build it, and then we'll go to the tests and run all tests. And you can see we are actually failing. We expected 3, our actual 0, and that's because I'm pretty sure I was looking at the complete count, not the incomplete count. So let's close this window, and yes, we were. So TDL.incomplete count is actually what we want to test. And we could go ahead and write a couple more facts, maybe tweaking a couple of these so that they'd be complete. In fact, we could hard code the fact that they start incomplete, and that might actually be a good idea because we don't know what kind of code changes somebody might make to this class, so that just forces them to actually follow our expectation. Here, let's do complete tasks, and let's go ahead and set just 2 of these to true. And these should be curly braces, not parentheses. Curly brace with parentheses following. There we go. Get my syntax right. So in this case, because we've set 2 of these to be true, we'd expect 2 to be in our complete count. And to save that, we can go ahead and run our tests again. And this time we'd expect all of those to pass. So we basically go through and write tests very much the way that we've done with our other types of classes. Now, where things get a little bit interesting is the to-do list implements the observable collection. That means that it is going to have a property changed event, and it's going to have a collection changed event that are both going to fire when either a property or the actual collection, the items in the collection, change. So those are a little more interesting to test. Let's go ahead and test that should notify of complete count changing on add. So that's a rather wordy way of saying that when we add something, we should actually get notified that the number of actually incomplete tasks have changed, because every time we add a new task, that task starts as false. So now we have 1 additional incomplete. So we're going to start with an empty list, and then we're going to do a assert property changed. And this assertion is one that actually listens for that property changed event. And this assertion takes a couple of different arguments. The first is the object that we expect to be doing the notifying, the object that implements that iNotify property change, so our TDL. And then the name of the property we expect to change, which is our incomplete count. And then an action. So this is a lambda expression, and that lambda expression should cause that assertion to be raised. So whatever we would expect to actually make that change. And in this case, we are looking at the add. So when we add an item to the list, we expect the incomplete count to go up by 1. So we would go ahead and just invoke tdl.add new to-do item test1, and I'm going to go ahead, like I did before, and ensure that our complete starts at false. This should actually be our expected behavior, but because this is a unit test, we don't want our code to depend on another class. In fact, this would be a better opportunity to use mock objects, which we'll take a look at here in a moment. But because we don't want to leave anything to chance, we will actually specify that this should have its complete property to false when it's constructed. And then that means that before it's actually added to the list, we know that it's incomplete. So we should go up by 1 incomplete. And once we do that, that should be our test. So let's go ahead and run the tests. And notice our notification test works perfectly. Okay, so we would do that for when we add items. We also need to think about the that changing when we change one of the items. So for example, public void should notify of incomplete count changing on task change. Or task completed. We'll call it completed. So this is also a very wordy description, but what we're actually saying is when we add something to the list, if that something changes, we would expect that to be reflected. So to do item equals new to do item. And once again, we'll make sure this starts as complete equals false. And we'll add our to-do item to our to-do list. And once we've done that, we're going to assert property changed again, to-do list, and incomplete. Okay, so our to-do item is already in the list, and it is set to false, so we expect incomplete count to be 1. Now, if we change its completion status, which we can do because we kept a reference to it, so we can say tdi.complete equals true. When this command executes, we would expect the to-do list to actually fire off that property changed event, which would notify us that the incomplete count is changing. It should also do one for the complete count, because the complete count also went up by 1, but we're only going to test one of those at a time. So now if we run our tests, we should see this new test also passing, and it does. So that's testing those properties. And like I said, we've tested the incomplete. We also need to test the completes. So this is not a complete set of tests by any stretch of the imagination. We're just doing enough examples to cover the things that we want to talk about. So let's move on to the next one. And the next thing we want to look at is that it should notify of collection changing or collection changed on add. So that we should also get a notification for the collection changed event handler, which gives us a notify collection changed event args, which is what we would actually process. Now, ideally, what we'd want to do is create our list, and kind of like we did here, we would use something like assert.property changed, but there is no corresponding assertion for collection change. They've only implemented the property changed in the library up to this point. So what we would look at instead is raised event. And this is a templated method, so we have to specify what kind of event args are going to be raised. And because this is a notify collection changed event. And if you're wondering where that comes from, that actually comes from system dot collections dot specialized, because that's where the observable collection is defined. And let's make sure I spelled that entirely right. Notify collection changed event args. So this is basically raised event is going to listen for an event that we're going to trigger, and then the arguments we're going to pass in are going to be all different Lambda expressions. So there's actually a listener that we're provided from this test, and we're going to tell it how to attach that listener to our event handler. So tdl.collection changed. And we'd want to attach our listener to that. So TDL collection changed, and then also how to detach it. This is kind of a generic approach for actually doing this. And the third argument we need to do is we need to provide, again, an action that causes that change to happen. So in this case, we would want to take our to-do list and add a new item. And actually, sorry, this is not raised event, it's raises. Raised event is one of the internal classes it uses. Now, ideally this would work. Now it's not, and if we look at why it's complaining, it's telling us that it is expecting a system event handler, system collection specialized, notify property change event handler. So it's basically expecting an event handler that is using the templated form of event handlers. But instead, we're using a different style of event handler. We're using a non-templated version. And this really boils down to a change that happened around .NET 2.0. So the very first couple builds of .NET and C#, when we created an event handler in a class, like a to-do list control, we would do it by writing a delegate function to represent that. So something like a public delegate to list handler, and that would take a object sender and a some kind of event args, which would probably be customized for our needs, and this would then become the definition for the event handlers that we would write in the future. Now, after templates and generics were actually introduced, we started switching to doing, instead of having the type be a to-do list handler, it would just be event handler, event args, with the kind of event args that we're dealing with. So this probably some event args. Whatever that event, those event args were, that was what actually would define what made this event different from other events. So instead of having a custom name, we would just have a templated event handler, and the custom name was really passed on to the event args. So this is kind of the new way of doing it, whereas the old way was more public delegate some like that. So you can see that these, oops, let's go ahead and give these a, there's a bit of a difference there in how we would actually define them, but they're basically doing the same thing. And that's what we're running into here, is the test that we're working with, this really relies on the class that you're testing having implemented the event listener using the old way of doing things, the old event handler, or sorry, the new event handler style, where we're using generics. So if this class was written before that point in time, like the observable collection was, it uses the old way, and this does not work. So really, there's no good way of kind of casting when we're dealing with these delegates, because casting a delegate to another type of delegate is actually a really dicey proposition. So this is not how we're going to do it for this kind of event. But for the newer defined events that actually follow that generic method, this is the way to go, because it's a lot less craziness in terms of what we have to do. Okay, so what do we have to do? Well, we have this event or object that we have implementing an event. We know what that event should look like, and we know what kind of event args we should get. So let's go ahead and define a variable to represent those. So notify collection changed event args. And I'm going to create one that is initially null. So this is just going to be a variable that we're going to hold around and use as part of our process. Now, we know that when we trigger this, we want to know, did the event handler get triggered, and then we probably also want to check some details about that event. And that's why we're going to create this event args. We're going to use that as kind of our basis for assertions. So the next thing we're going to do is we're actually going to take our TDL and create a collection changed event listener. So we could define this as its own method, but we can also use lambda syntax to do this. And it's a lot quicker to use lambda syntax to create an anonymous inline delegate, and that's what we're going to do here. So sender is going to be our first argument, and E for the event args. And then in the body of this function, what we're going to do is we're just going to take this args variable we defined there. We're going to assign it this value of this collection event args, notify collection event args that's coming in from the collection changed event. So that will give us access to this event outside of the body of this anonymous function. And this is also one of the really nice things about using anonymous functions, is now args is actually in the same scope as this entire expression, so we can actually use it. This is called variable bootstrapping, by the way, where we apply a value inside of something like a lambda expression to basically pull in a value that's down in a lower scope and kick it up a level into the next scope. Now, this also will only work because of the way that C# does events. C# events are triggered synchronously, which means that as soon as we do something that triggers that event, we go out and reprocess all the event listeners, trigger all of those in turn before we continue executing our code. So if we do something like t.add or tdl.add, so adding a new event, which we're going to add a new task, a new to-do item. Then as soon as we've done that, this event handler should get triggered before this execution ends this line. So as we pass from this line, before we reach the next line of code, we're actually going to trigger this guy. That works because this is an asynchronous operation. In languages that do things asynchronously, there's a possibility we get to this next line and execute the next line of code before this ever gets processed, and therefore the value of args would still be null. So if this happens to be an asynchronous based event language, or if you're using C# and you're using an asynchronous event, there is such a thing in C# as well, this approach will not work. But because we're doing this synchronously, this will. So we can now assert that, for example, this variable args is not null. And that would tell us that we indeed added our new item. So let's go ahead and run that. So if we take that test and run it, You can see it passed. We got what we wanted out of that, so that is working. Now we could do a few more assertions on this as well. For example, we know that on the collection changed event, the first argument should be a description of what that event actually is talking about. So did we add something to the list? Did we remove something from the list? If you remember, when we were handling these guys, we actually looked at this notify collection changed action and saw was it an add, a remove, or a reset, because those were the different possibilities. So we want to go ahead and check that. Let's go ahead and assert dot equal, and we expect the notify collection changed action to be add in this case because we just added something, and then we're going to check that our args dot action matches that. So if this was an add, we'd expect that to be what was added. And then we can go one more, and rather than adding a to-do item that we're not keeping track of, let's go ahead and keep track of it. So TDI equals the new to-do item, and then we'll add that. We can also make sure that the item that we added is actually properly in that action. So we can say assert dot equal again that we want TDI to be equal to args dot new items, which is a list, and we would only have one new item because we only added one thing. So we'd expect new items at index 0, so the very first item in that list, which should be the only item in the list, to equal the item we actually added. And these three together are really the most important things we care about with those if notify collection changed event args. Did it tell us that we did actually add something? Did it tell us that the action was an addition, and did it tell us what the item that was added was correctly? So now if we go ahead and run this test again, you notice it still passes, so all three of those assertions are being hit and being processed the way we expect. So that's kind of the workaround that we can use to test that we're actually correctly adding things to the collection. Removing items from the collection is going to work very similarly. We're going to go ahead and put the item in collection before we start listening for the collection changed event, and then after we've set up this event listener, we'll go ahead and pull out the item with TDL remove, and then we'll make sure that it notifies us that something was done, that collection changed action was a remove, and that the removed items contains as its first and only argument the item that we're interested in. And if we wanted to make sure this was the only item that was in there, we could also do an assert dot equal and look at the count. So we'd expect just one item in args dot new items dot count. And we could also assert that the other one is empty, which would be args.old items, because we're not removing any old items. Let's go ahead and run that one more time, just make sure that none of those break on us. And I was thinking that might actually happen. Value cannot be null, parameter collection. So old items is actually null in that case because, yeah, so we could just test that it's null. Because they don't even create the collection when it's an add for the things that we're removing. So yeah, now I'm running the list. So that's the basics of kind of writing some of the traditional unit test side of dealing with a WPF app. So we do that for basically all of the code, all of the model code. And in fact, if you do a bit more research into WPF, they've also created an architecture called the model view model, which basically has model classes that we can test, has view models which do any kind of special transformations we need to do in order to get things into the view, but it does it again in just a generic straight up C# class, so that's easier to test. And then anything that is actual WPF or actual XAML files, so the XAML plus the backend, really becomes nothing more than a very thin layer over the top of the models that just uses data binding and uses event handlers and commands to hook it all up. up, so that there's very little going on in the GUI that really has any calculation to it. It's really just, are they hooked up correctly? And part of the reason for that is it's actually very difficult to test GUIs using automated tests. There are a handful of techniques out there, and none of them are quite really where we want them to be in terms of, does it actually tell us the things we care about with a GUI, which is, can we actually see the controls? Can we use the controls? Do they make sense? Are they something that a human can interact with? And the best way of testing GUIs is still, honestly, to have a human go through it. So have a human launch your project and just do the things that we would normally do. So create a task. Does it add? Can we see it? Can we check the box? When we check the box, does the number change? Test 2, can we add 2 tasks, 3 tasks? And if we check 2 of those, so basically the kind of playing around that we would normally do. Now there is a problem with this approach, and that problem is basically that when we do tests this way, we don't often have the rigor we want. The nice thing about writing an automated test is that every time we run that test suite, we know exactly what tests are going to be run. They're all going to be run against all the code. It's always going to be done exactly the same way. When a human does this, we don't necessarily always follow the same procedure. We may add 3 items one time and just 2 the other, or maybe we forget to double check that we can check multiple boxes, or we sit here and we flip the boxes but we forget to look at the items remaining. So all of those kinds of concerns about how do we actually test this effectively. So in order to ensure that kind of rigor that we want, we do something where we write what's called a test plan. So I'm going to create a new Word document, and we're going to write ourselves a little test plan. So this is to do list test plan. And I'm going to go ahead and make that the title heading 1. So we're going to create a test, which is adding items, and really how you word this and everything, a lot of times your company will have a template they'll want you to follow, but it really just, what's important is that you get the idea out there of what you're doing, and we're going to step by step kind of walk the tester through what they're supposed to do. Fire up the application. Step 2, type into the task panel the text test 1. Okay, so fire up our program. That's step 1. And actually, before we even move past that, we should say something that you should see a window like this. And we want to use as much as we can to not leave things to the imagination. So what we'd really like to do is just kind of show them exactly what this looks like. And one of the ways we can do this in Windows is if you hold Control-Shift-Alt and then print screen, that actually copies an image of this to the clipboard. So then we can just paste that image in, and there we go. We should see a window looking like this. Type into the task panel the text test 1. And to help our user know what we're asking them to do, we would go ahead and do another screenshot and help call their attention to the part that we care about. I'm going to go ahead and fire up Paint for this, because we really don't need a fancy graphics package for this, but what we really want them to look at is just this part down here. So I'm going to expand the ribbon a little bit so that I can actually get my crop going. And I'm just going to crop that piece out. So I select, and then we do this crop operation. So that shows exactly what we're looking at. And I'm going to put a red ringed rectangle around where they're supposed to be typing, just to kind of make that clear. And we can even give them a little bit of guidance. Okay, so then I'm going to click off of that. If I Control-Shift-C, I believe that should copy it to our clipboard again, and I can go ahead and paste that here. Nope, didn't copy everything I wanted to copy. So I'll go ahead and do a select operation. Select, just grab all that, Control-C, and then we Control-V. So now we're saying, okay, type into the task panel the text test1, 3, click the add task button. And if I come back over here, I can just undo those 2 additions, and now I can go ahead and do a red ring around the button I want them to click, and we'll select everything again. And then we should say something like, your task should appear in the list with an unchecked checkbox. And let's go ahead and make that step 4. So we add our task and look, it appeared up there. Control-Shift off to print screen. Paste that back in. So now we have the appearance, we have the test1, we have everything going, and then we just go ahead and say, and the items remaining should now be 1. And again, if we want to call their attention to that, we could go ahead and mark the areas that are important for them to look at. This test1, this 1 item remaining. If we do that, Control-Shift A, or just select all of that and paste that over the top of that. And I didn't paste it over, I pasted an extra one on. So you can see we're pointing out what we're supposed to be looking for. And then step 5, if you check, well, let's just say check the box next to test1. And I'm just going to say checkbox next to test1. And items remaining should now be 0. Somehow I bolded that, so we'll unbold that. And we'll come back over here, check that, Control-Shift-Alt, print screen to copy it, paste it in here, and didn't quite get it. Control-Shift-Alt, print screen, Control-V, and we'll go ahead and circle again, 0 items remaining, test1. This time I don't think we need to grab the whole window because there's nothing important changing down below. Go ahead and crop it to just this portion. Actually, we didn't even need to crop it. We could have just copy pasted that piece. But there we go. And then we might just clean up the formatting a little, make it easier to read. Actually, we don't have a extra line there. Yeah. So that would be one test. And then we might have a test of adding multiple items. So we go ahead and continue from here, add 2 more items, and make sure that the items remaining updates correctly as we were expecting. And then maybe do a test on removing items. But the idea is what you're doing is you're setting up a sequence of steps that a tester should use to make sure that this works the way we want. And then a lot of times in a test plan, we'd also have places for them to mark down it worked correctly, or that might be a separate document, or sometimes an Excel spreadsheet, or even some kind of custom software where they're going to mark what's all passing. And then if anything's not passing, they're going to provide a description of what went wrong, maybe a screenshot, and that's going to go back to the developers to actually fix the program. Now you can see doing that means that we're bringing in a lot of extra employees to do this testing, and that they're doing this process manually, which means it's going to take a little while for them to go through all these steps and put together that response that they need to send back to the developers. So this is not going to be the instantaneous response you get from an automated test, or near instantaneous. This takes a lot longer. So it takes more time and it costs more money, which is one of the reasons why we see companies really focusing on the automated testing rather than trying to do everything this style, which is actually how we used to test software before we started developing automated tests. But some things we still can't test any better way than putting a human being in front of it. And one of the big things is GUIs. GUIs just really, you need a person's eyes on it, at least at this point. There are some new techniques that are being developed using AI and some stuff like that maybe in a few years will change that. And also there's some really good technologies that have been developed in the web world to do this kind of testing that actually make it possible to do some automated tests against the GUI rather than necessarily having to have human eyes on it. But in the WPF world, we're not to that point yet. So this is kind of some of the strategies that you would commonly see. So this is writing our test plan. And then this document, we would just go ahead and save this once we finished writing the rest of our tests. And I would probably put it in that exercise. So in my case, that's in the CS400 folder, and exercises, data binding exercise, data binding exercise, data binding exercise. And then here you can see we're in that project. We have the data binding exercise to do tests. I'm going to add a new folder for documentation. And I'm just going to save that plan in the documentation folder so that that is there. And we could potentially add that to our Visual Studio project as well. It's not necessary, but we could. So maybe add a folder. Add a folder, maybe to the testing project, and why won't you let me rename this? Where's my rename option? I don't know why it won't let me rename the folder, but we could add an existing item, and if we jump up a level, documentation, and make sure that we're displaying all files, there's our to-do list test plan, and now we've got it in that project. I mean, it won't compile, it won't do anything. It's just makes it obvious that we have it there. And the important thing is that when we commit this to GitHub, that we also have that file in there. So if we go to, for example, where's the terminal here? It's under Tools. How did I get a terminal open earlier? Oh, open in terminal right there. So this opens PowerShell, and I can go ahead and do my git status there, and notice that it tells me I've modified this and I've added this documentation folder. So we can do a git add all, and then git status. Now those are all staged, and notice that it also staged the test plan. And actually, because I added it as an existing item, it actually got added to both places. So it's in our new folder and in the documentation. So you might not necessarily do it that way, but git commit -a-m added tests. So that then commits those changes, and then I do a git push origin master to push it up to my origin, which would be GitHub for your assignments. So that basically walks you through the process of creating a test or a set of tests to work with WPF, and also how to write a testing plan to deal with the GUI side of testing a WPF application, because there's not really at this point a great way of doing that in an automated fashion. So that's it for today. Go ahead and make those changes on your project and get them pushed up.